Okay, here are the notes. We are continuing on finding exact values. So again, copy this down in your notebooks. Find the exact value of each trigonometric function. Of each trigonometric function. Okay, so we did start this on the last assignment, but we're going to continue it here. Now they're going to ask you not just sine, cosine, and tangent, and not just simple angles. So we'll go over a couple of examples here. It's really not much new. So here it is. So again, let's review. Let's say they're asking you to find the exact value for sine of 240 degrees. Okay, and again, on the last assignment, they drew it out for you. So you have to draw this out, right? You got to see the angle, you got to see the quadrant, you have to see the reference angle, you got to draw the triangle, all that good stuff we've been learning. So got to make sure we draw the triangle first. We got to have an XY axis. 240 is 90, 180. It's going to be, remember these angles that they're giving you, the reference angle is going to be, right, wherever this 240 degrees is. This reference angle is either going to be a 30, a 60, or a 45. In this case, it's what? 180 plus 60. 180 plus 60 is 240. You're only dealing with these special right triangles for these angles, these specific angles. So I know this is 60 degrees. Okay? And this is why you're able to find these exact values, because it'll be 30, it'll be 60, or 45. And when we're working with these 30, 60, 90, 45, 45, 90, we know that we can pick a point there just somewhere and drop an imaginary triangle, because we know how the sides should go for a 30, 60, 90, or 45, 45, 90. So in this case, this one's going to be 30 and 60, and we know that's 90. And then we come over here, and how do we label a 30, 60, 90? We got 30, we got 60, I got 90. Remember, it's across from 30 is, opposite of the 30-degree angle is x. This is 2x, the hypotenuse, and this is x root 3, and you're going to pick the value of 1. 1. Let x equals 1, so this will be 1. But again, watch out, it's on this side, so it's negative. 2 times 1 is 2, and 1 root 3 is the same as just root 3. And again, this is also going to be a negative. Always check your x and your y to see if it has to be negative or positive. Just the x or the y. The hypotenuse doesn't have to. Here, they're not asking you for a point on the terminal side, but you know that it would be what? Negative 1, negative 3, right? If they ask you for this point, right? That'll be true on the test. Negative 1, negative root 3. But they're not asking you for that, but I know we know that already. They're just asking you for one of them. Now, you could essentially sit here and do all of them. You can do sine, you can do cosine, you can do tangent, and you can find the other three, which you'll see right now. I might ask you on the test to do all 6. You should be able to do all 6, right? Once you have this, you know that this is your hypotenuse side here. This is my hypotenuse side. This one is the opposite side, opposite of the reference angle, and this is your adjacent side. So again, what I'm saying is they're only asking you for one, but you should actually be able to sit here and find sine of 240, cosine of 240. I mean, you can find anyone, right? Tangent of 240. And on the test, I am going to do that. I'm not going to ask you just for one. You're going to find all 6. Well, I know that here they're only asking me for sine, which is sol, which is over h. I know that. And I know this is ka, and I know this is toa. But again, what's new is here, they're going to not only ask you for these easy first 3, they're going to ask you for some of the other new 3, but you have to get these 3 first. To answer this question for sine of 240 is negative root 3, because that's the opposite side, over 2. That is the answer for this, just one specific trig function. But I'm telling you in the test, I'm going to ask you for all 6. Again, you should be able to do all 6, right? And that is it for that one, right? Or they could have asked you here for cosecant or secant or cotangent. You would have done the same thing. You would have done the same thing, but remember, you find these 3 first. All right, let's do one like that. Number 2. Let's go with secant. You see, here we go. Secant of 150. See, don't worry about the function yet. You worry about drawing the angle. You worry about doing the triangle, labeling the sides. Again, they'll ask you for 1, but you'll have all the information to be able to find all 6. Okay, so quickly again here, secant of 150. Well, I got to go to 150, right? And we are doing 90 plus 60. 90 plus 60 is 150. Right, 90 plus 60 is 150, but the reference angle is what I'm working with is 30. And that's why I asked you to practice always putting these 2 angles here in your quadrants. 90 plus 60 is 150. Here's my terminal side for 150. Again, always draw the triangle, right? Pick a point. Always draw it down to the x-axis. So again, we're working with another 30, 60, 90. Going back to number 1, look, number 1 had the 60 degree as a reference angle. This one has the 30 degree as a reference angle. So it's going to be similar, but it's going to work out different, right? So I know this is a 30, 60, 90. You're going to have either 30, 60, 90 or 60, 30, 90, same thing, right? Or the 45, 45, 90. Okay, so we're doing the same thing. If my right triangle here is in this orientation, I would know that what? Let's see, how do these sides go? Remember? Let's see, if this is 30 and this is 60, make sure you label these right. I know that the hypotenuse is 2x. I know that the side opposite of the angle of 30 is the O side, which, I'm sorry, is the x side, the opposite side, and this is the x root 3 side. Right? Label those correctly. If you label these wrong, oh, everything's going to be wrong. You pick 1 for x, so this is 1. This is 2. And this is 1 root 3, or just root 3. And again, always check your x and your y. Any of these have to have a negative? Nope. This one positive up. This one here, your x. Nothing else is going to tell you. You're going to have to know when to put a negative and where to put it. Okay? Right, because we're on this side of the x-axis, that's negative. This one, we're on the positive side going up on the y. It doesn't need a negative. Well, the hypotenuse is always positive. All right, and again now, this is now when I look at the function and I'm like, okay, well, they didn't want a sine, cosine, or tangent, but you're still going to have to find it. Again, remember on the test, I can find all of them. They probably just, here they're only going to ask you for 1. On the test, I'm going to ask you for all 6, right? So just make it a good practice. If they're not asking you for sine, cosine, and tangent, and they're asking you for one of these other new 3 ones, you have to go through these first. So get these 3 first. So I know sine is over h. I know cosine is a over h. So, ka, toa. And I can find all these 3, right? But which one's the one that I need, or that's the reciprocal function of secant? The reciprocal function of secant is cosine. So I really only have to work with this one. So cosine is a, oh, I didn't label my sides. Go back over here. Don't just see a blank paper here. Let's see. This is obviously the hypotenuse side. This is the opposite side. Here's my A. Okay, now I won't get it wrong. A is negative root 3 over 2. But the question wasn't cosine, remember? I need to know cosine to get secant. Okay, now I can get secant. If this is true for cosine, what's secant? Well, then secant would have to be what? The reciprocal of that, which is, and again, the negative, just keep it on the top. The negative you don't have to put it on the bottom. Well, that would be negative 2 over root 3, right? And can we leave this answer like this? Nope, can't leave it. You got to fix it. Cannot have a radical in the denominator. So that would be secant of 150 would be equal to, well, I got negative 2 over root 3, but I got to multiply, right? Rationalize the denominator. That's what it's called when you do this. Okay, the correct and final, the answer in the correct form would be secant of 150 is equal to negative 2 root 3 over 3. And nothing can reduce, always just look at the whole numbers, not the number in here. This is your answer for the secant. Again, we're doing the same thing, it's just, if they don't ask you for a sine, cosine, tangent, if they ask you one of these other ones, you still got to go through and find sine, cosine, or tangent, and then do the reciprocal function. Really not doing anything new, right? Let's look at another one. Okay, number 3. What about cotangent of 900? See, now they're going to give you some, we're going with these new 3 and these bigger angles, right? How do we get the exact value for 930 degrees? Well, we have to get 930 degrees correct. All right, 0 degrees, 9 times 1, 9. 9 times 2, 18 with a 0, 180. 9 times 3, 270. 9 times 4, 360. 9 times 5 is 450, 45. With a 0, 450. 9 times 6 is 540, 54. 630, 720. 9 times 8, 9 times 9, 810. 9 times 10, oh, this is 900. Oh, this is 900 here. So then this is a 30 degree, right? All the way to here is 900 plus 30 degrees. There's your 30, 930 degrees is right there. Long story short, you should be here in quadrant 3 with a 30-degree reference angle. Okay? And we're doing the same thing. That's 30, that's 60, that's 90. We know the hypotenuse is 2. Across from 30 is 1. This would be my root 3. And then look, these will have to have a negative. Don't miss that. And then the question is, I'm not going to find cotangent directly. You're going to find the one that is the reciprocal of cotangent. You find that one first, and I know that it's what? Tangent. If tangent of, that's ugly. If tangent of 930 degrees is what? Tau over A. Oh, let me label my sides. O, A, and H, but I'm not using H. If tangent is O over A, that would be negative 1 over negative root 3. Don't bother fixing it. Why? Because if this is, oh, by the way, and the negatives cancel, so it's really 1 over the negative and negative make a positive. If the tangent is this, that's fine. I'm not going to fix it because then when I do the reciprocal, which is cotangent, it'll be the square root of 3 over 1, right? And really, the square root of 3 over 1 is just what? Root 3. That's the answer for this one. The exact value. Again, on the test, you're going to do all 6. But here, they're just asking you for one specific one. All right, last one again, real quick. What do we got? Number 4. What about a cosecant of negative 870? Negative 870. Well, got to draw it out. Got to see where it is. I don't know which quadrant it is. Going negative. Negative, we're going clockwise now, right? That's 0, and then I go around, that's negative 360, and then I go around again, that's negative 720. Negative 720, that's 9 times 8. 9 times 9 is, this will be 810, which is negative, so that would be what, 60 more? 60 degree more that way. So if this one's 60, that means your reference angle is 30. This is where we're at. We're working right here with the reference angle. Don't ever work with, always the one with the terminal side and the x-axis. Don't work with the y-axis. We drop it down. And yeah, we actually got the same triangle as this, don't we? Look at that. We got the same triangle, but it's a different problem. So I'm going to label the sides the same, right? It'll be negative 1, it'll be negative root 3, it'll be positive 2. But now they're asking you for a different function. What is the reciprocal function of cosecant? I got to find that one first. You got to have the sine, the cosine, or the tangent first. The reciprocal function is sine. So if sine of negative 870 is, sine would be what? O over h. This is my opposite side. This is my hypotenuse side. If sine is negative 1 over 2, if it's true that sine is that, I have to know this one first to get cosecant, right? So if that is true for sine, then what? Then that means that cosecant of negative 70 degrees would be the reciprocal of negative 1 over 2, which would be negative 2 over 1. And the answer is what? Negative 2, right? Okay, there it is. Easy.